Problem 21.1. Excess electrons are placed on a small lead sphere with a mass of 7.90 grams so that its net charge is negative 3.10 times 10 to the negative 9 coulombs. A. Find the number of excess electrons on the sphere. B. How many excess electrons are there per lead atom? The atomic number of lead is 82 and its atomic mass is 207 grams per mole. So to start off with part A, a good thing to know would be how many coulombs there are per electron. So I'd have this written out here for us right here. And essentially what you're going to do, because we're going to basically assume that all of these lead atoms are neutral, otherwise, at least to begin with, they're neutral, and then we put the charge on there to the point where it's negative 3.10 times 10 to the negative 9 coulombs. All of this comes from the excess electrons, of course, and so what we're going to do is just some simple dimensional analysis, and we are going to divide this here, the amount of coulombs in a single electron, with this, so that we get this number right here, and that is, just take negative 3, 10 divided by negative 1.602, we get 1.94 times 10 to the 10 electrons. And this is just a row number, it's not like moles or anything like that. Nothing fancy like that, but we'll have to get into that in a second here. For part B, essentially what we will want to do is take the is this right? No. Take the mass of the lead. You're going to want to multiply it by the amount of moles and divide it by, at least the moles per gram, multiplied by the amount of moles per gram, 207 grams of PB. And then from there, we have essentially the amount of moles. Now, the problem with this is that this number right here is in moles. If it was, then we could easily just divide it out right there, but we need to actually multiply it by Avogadro's number. So there's 6.022 times 10 to the 23rd atoms per mole. And so essentially, just gonna put that right in our calculator. And we've got this number right here. How many actual atoms there are. Let's run that up. How many atoms there are per or for the sphere. So to keep the units there. So then essentially what we want to do is divide the amount of electrons we have by the number of lead atoms we have. That's how we get our number of electrons per lead atom. Pretty simple. I got some comments earlier about dimensional analysis. Make sure you put some parentheses in here. Like, not every calculator is the same. I always just use parentheses as much as I possibly can just to be safe. Yeah, just good rule of thumb. Always parentheses. So the number that I got here was 8.43 times 10 to the negative 13 electrons per lead atom. And so basically, the reason why we do this, the reason why we don't actually need the atomic number, like, I think that's just to, like, maybe throw you off, is because it asks for the excess number of electrons per lead atom as opposed to the number of electrons per atom. So these will be your answers right here. Yeah, let me know if you got something different and I can help you out, or maybe you could help me out if I got this wrong. Leave comments for any questions that you want me to solve. Thanks.